To solve the problem, list the nodes and divide it into vertical and horizontal directions. The car has an initial x velocity of 62.6 meters per second and is jumping off a cliff that is a height of 35.7 meters. The acceleration in the x direction is 0 meters per second squared, meaning the car has a constant x velocity throughout the jump. The goal is to solve for the x value, or the distance the car will travel before the car's wheels touch the ground. There are also other unknown values that are not explicitly stated in the problem. Gravity is negative 9.8 meters per second squared, and the initial y velocity is 0 meters per second because the car is not falling at the start of the jump. We will ignore final x velocity and final y velocity since it is not needed to solve this problem. This leaves us with two unknown values, the time the car is in the air and distance. However, this is still solvable since time is not affected by the x direction or y direction. In other words, the two directions share the same t value. Therefore, we can solve for the y direction to find the t value. Here, I use the second equation to solve t in terms of y. This is my work down here. Since v of 0y is 0 times t, that cancels out. And I'm left with 4.9 t squared equals 35.7. I divide 4.9 t squared by 4.9 to the other side to leave t squared by itself, and I'm left with 7.29 equals t squared. When I square root both of these sides, I'm left with 2.7 seconds equals t. I will borrow the t value from the previous equation and input it into this equation to solve for x. The right side cancels out since it is multiplied by the x acceleration 0, and after simplifying I am left with 169.09 meters. Since the video game calculates the distance in feet, I convert my answer from meters to feet so I can compare it to the distance the car will reach in the game.